Welcome to this video on conditional probability. After watching this video, you will be able to define conditional probability, state the conditional probability rule, calculate conditional probability of an event, and use a contingency table to calculate conditional probability. Note that this video assumes familiarity with basic probability and contingency tables. Please watch my videos entitled Basic Probability and Contingency Tables before viewing this video. Conditional probability. The following notation is used to express conditional probability. The notation is read as the probability of event B occurring given that event A has already occurred. Let's break this down. The P stands for probability, so we read that as the probability of. B stands for event B occurring, so we say the probability of event B occurring. Then we have this vertical line, which might be new notation to you. This vertical line between B and A is read as given that. Lastly, we have A, which is read as event A has already occurred. Again, remember the vertical line in conditional probabilities is read as given that. Let's take a moment to practice reading some conditional probabilities. I'll put the conditional probability on the screen. Pause the video, read it out loud to yourself, and then unpause the video to check your pronunciation or your explanation of the probability. Here's the first one. Pause the video. We read this as the probability of picking an ace given that the card is red. Let's do another one. We read this as the probability of picking a blue candy given that the candy is an M&M. Let's do one more. We read this as the probability of picking a person who is married given that the person is male. The conditional probability rule. The conditional probability rule states that for any two events A and B, the probability of B occurring, given that A has already occurred, is equal to the probability of A and B occurring divided by the probability of event A occurring. Notice that we can simplify this by saying that it is also equal to the number of ways that A and B can occur at the same time, divided by the number of ways that A can occur. Notice that the notation n parentheses is read as the number of ways that. Applying the conditional probability rule. Example 1, rolling a die. Part A, suppose you roll a fair six-sided die. What is the probability of rolling a 3? Here are the possible outcomes. Since it is a fair die, we will assume that all of these 6 outcomes in the sample space are equally likely to occur. So we can use the general probability rule, which says that the probability of an event is the number of ways that an event can occur divided by the total number of possible outcomes. There's only one way to roll a 3, and there are 6 possible outcomes. So in this example, the probability of rolling a 3 is 1 over 6. Now let's change this up a little. What is the probability of rolling a 3 given that you know that the dice roll was odd? So let's examine this. We can again use this basic probability, and we know that the number of ways to roll a 3 will be on top, but the number of possible outcomes has diminished. Instead of looking at the entire sample space, since we know that the dice roll was odd, now we're only looking at the number of ways there are to roll an odd number. So there's still only one way to roll a 3, or one outcome that represents rolling a 3. But again, instead of dividing by all 6 possible outcomes, we are only looking at the outcomes that represent odd numbers, since we are told that the outcome was an odd number. So the new probability, instead of being 1 over 6, is 1 over 3, because there are 3 ways to roll an odd number. Let's calculate the same probability, but this time we will actually use the conditional probability formula. Remember, that formula states that the probability of event B occurring, given that event A has already occurred, is equal to the number of ways that A and B can occur at the same time, divided the number of ways that A can occur. So the probability of rolling a 3, given that the number rolled was odd, can be expressed in this formula as the number of ways that you can get 3 and an odd number at the same time, divided by the number of ways you can get an odd number. How many ways can you roll a 3 that is also an odd number? Well, 3 is an odd number, so there's still only one way that can happen. Saying 3 and an odd number is kind of redundant. How many ways can you roll an odd number? Well, in the last slide, we already said that there are 3 ways that could happen. We could get a 1, a 3, or a 5. So we still get 1 over 3 as our probability. This time we just sort of looked at this probability or this problem through a different lens by applying the conditional probability formula. Applying the conditional probability rule, contingency tables. Here you can see that in this augmented contingency table, I have added a final row that represents the subtotals and the grand total, and a final column which also contains subtotals and the total. If you have not already watched my video on contingency tables, please watch that to figure out or to understand how to calculate these totals both manually and using Microsoft Excel. Let's get started. So in part A, we want to calculate the probability that a randomly selected person is married. And in part B, we're going to calculate the probability that a person is married given that they are male. One of these probabilities is a simple probability and the other one is a conditional probability. Can you figure out which is which? Pause this video and write down your answer. Calculate the probability that a randomly selected person is married. Is this a basic probability or a conditional probability? This is a basic probability problem, so we can use the equation that the probability of an event is equal to the number of ways the event can occur divided by the number of possible outcomes. Putting that into the context of the problem, we see that the probability of a person from this table being married is equal to the number of married people divided by the total number of people surveyed. As you can see, the total number of people married as represented in the table is 127.5 million. Then we divide this by the grand total of people represented in this table, which is 251.3 million. That gives us about 0.51 or 51%. Part B, calculate the probability that a randomly selected person is married given that they are male. This time we have a conditional probability problem, and we know that because we see the phrase given that. So remember, the conditional probability formula says that the probability of event B, given that event A has already occurred, is equal to the number of ways that A and B can occur at the same time, divided by the number of ways that A can occur. Putting that into the context of this problem, we see that the probability of a person being married, given that they are male, is equal to the number of people who are male and married, divided by the number of people who are male. So from this table, you can see that the number of males who are married is 64.4 million, and the total number of males represented in this table is 122.5 million. So dividing those two numbers, we have about 0.53 or 53%. Part C. In the last problem, we found the probability that a person was married given that they were male. Now let's find the probability that a person is male given that they are married. Are these two probabilities the same? Pause this video, write down your answer, and then unpause it to see if you are correct. In other words, is the probability of B given A the same as the probability of A given B? Remember, the conditional probability rule states that the probability of event B occurring, given that A has already occurred, is equal to the number of ways that A and B can occur at the same time, divided by the number of ways that A can occur. So let's go ahead and calculate the probability that a randomly selected person is male, given that they are married. Again, we have a conditional probability problem, so we can use the formula, the probability of event B occurring, given that A has already occurred, is the number of ways that A and B can occur at the same time, divided by the number of ways that A can occur. Putting that into the context of this problem, we have the probability of a person being married, given that they are male, equals the number of people who are married and male, divided by the number of people who are married. So again, just like the last example in part B, the number of married people who are also male is 64.4. So at least the numerator is the same. The question is is the denominator the same or different from the last probability we calculated? And the answer is it's different, right? Before we were dividing by the number of males. This time we're dividing by the number of people who are married, which is 127.5. So when we divide those two numbers, we get about 0.51 or 51%. So we can see that the conditional probability rule is asymmetric. To answer the question, is the probability of B given that A occurred the same as the probability of A given that B occurred? And the answer is no. If we look at the probability of B given that A occurs, we get this equation. And notice that whatever the second event, that after the given that phrase, goes down into the denominator. Looking at it the other way, the probability of A given that B occurs, again, we take that second event, in this case, event B, and we put that in the denominator. So hopefully you can see when you compare these two probabilities, the denominator is different. The numerator is the same, right? The number of ways that A and B can occur at the same time, but the denominator is different. So therefore, they result in different probabilities. At this point, having watched this video, you should now be able to define conditional probability, state the conditional probability rule, calculate conditional probability of an event, and use a contingency table to calculate conditional probability.